by some scientists in the 50s, before we had computers that could do all of this, and they wanted to try to understand how water flowed in Puget Sound and like what the circulation was like. So they built this scale model, and then it does what the sound does. Okay, so then Puget Sound, it has sort of 4 basins, is what we call it. There's a main basin, which is the big deep one that runs from sort of Tacoma all the way up to Admiralty Inlet, which is what leads to the Strait of Juan de Fuca over there. Then we've got Hood Canal over here, Whidbey Basin, and then this part is just sort of South Sound.
One of the things that's important about both Alexandria and their sigma is that they are actively swimming cells. So when I came into oceanography, I was surprised to learn that what I think of as plants are actually swimming, and they're very motile. And so this is a petri dish full of heterosigma, and they're swimming, and their swimming is creating these patterns. This is sped up by a factor of about 10. They monitor the water constantly, and there were no cells, and all of a sudden, within less than a day, there was this massive invasion of these cells, and all the fish died. And so this is the kind of effect that this alga can have. We're going to set up a very quick experiment, and this is going to be the experiment, and we'll try to replicate it and see if we can get it to work. So these are 2 test tubes with heterosigma cells in them. See how brown they are? There are quite a few there. And they're the same test tube, they're identical test tubes, except in this one, there's a little bit of fresher water laid on the top. Layers on this side. Let's leave these as the controls. So I need 5 of you with steady hands. Actually, see if you can fill it up, because I think these are pretty wide test tubes for this. There. So see if you can do that. And the idea is to put it close to the surface so as to mix it as little as possible. And we'll see how that works. And then what we'll do is we'll come back after you work with the model and see if we've succeeded in getting a layer.
So this is Agate Passage right by your guys' school, and you can see that there's this water gets stretched around, and there's a cool vortex over there. But so one cool thing about the model is that it's controlled by a computer, and so it's doing like the real tide. And the computer over there will tell you what date it's simulating right now. So it's doing sort of the real thing. And I think I started it like when I came in this morning. It started today, and so now it's in the future sometime. But you can set it for sort of any date. You could go back and set it to like some day that you were interested in, and it would do what was happening in the 50s. So before we had computers, they made this thing to control the tides instead, and it's a really complex sort of like clockwork mechanism. And all the river flows are controlled separately too, and those are realistic. Those are back here, but it's like the Skagit has a lot more water flowing through it than the Duwamish or something else. Yeah, this is the tide maker, and this is not as complicated as the one out there. So this is just doing it doesn't change or anything with the date. It's just going up and down and up and down. And then over here we have our fake river, and it's very fake because there's, you know, the mountains over here and a little drip right here. And there's just this little paper here to stop it from dripping in, and it makes it more steady. What happens to that sill first? Okay, so what does the sill do? Stuff's going back and forth.
And it goes up to like a little bit more.
And it also has these little nice eddies, sort of every time it goes, when the water's going this way, it kind of spins on here, and then when it goes this way, it spins that way. And we're just going to watch what happens to this one over time. And now this one takes a little bit, so while we're waiting for that one, someone else, I want to volunteer for fresh water, to just put a little bit, very gently over here. Over here, sort of right next to the river, just a little bit. Yeah, that's great. So we'll watch what happens to this over time. Okay, so let's come to this salt water first. So what's happening to this salt water?
It's going back and forth.
At a steady speed.
Yeah, it's going back and forth, but it started out kind of like this, right? And now it's kind of stretched in this way, right?
So it's gotten longer.
Oh, I see it. Look, you can see it stretch every time it changes direction.
Yeah, every time it's changing direction, it's kind of stretching. And the stuff that's kind of lower is moving this way, and the stuff that's up higher is kind of going this way. And so you're going to see that this is kind of flattening out into this nice flat layer. And eventually this bottom part is going to work its way over here, and the top part's going to work its way over there. I think this one's cool. Okay, so meanwhile, the freshwater, what's happening over here with the freshwater in our river?
stretching now.
It's stretching out. But so now here's a question: which one's faster? The freshwater over here is stretching at one sort of speed, and the saltwater there is stretching at a different speed. Saltwater stretching, okay, and that's kind of weird, right? Like, why would it be stretching slower over here than over there? That's sort of, we don't have to answer that yet, but that's the cool thing. And finally, let's look at what's happening to freshwater. I need a freshwater volunteer again. Okay, and I want you to just do a nice big squirt, sort of gently, you can stick the tip in, and just sort of right before the narrows. Yeah, right here. That's perfect. It's okay. So you'll notice that river, the stuff that we stuck in the river is still going really slowly. It's still basically all together, and it's in this tiny little layer. But then it gets to here and it mixes a lot.
Guys, you were very careful.
And there they are.
There they are.
See it.
Some of the, it's easier to see in the big test tubes than the little ones, but you guys did a great job.
So, this won't be finished by the time that you guys have to leave, but we're going to send it to you guys later. So what we're making is I went on this website called Thingiverse, where lots of people just share all of these things for 3D printers. And I'll show you what we're making. So, well, first of all, before I show it to you, because it's kind of cool to see what it is ultimately, but first of all, if you look at this, you can see that it's kind of making all these crisscrosses and stuff. So it's kind of like a hot glue gun, but it's on like a motor, and it can move around, and it's squirting plastic and stuff. And it can just build things layer by layer. That's how the printer works. But so what we're making is this.
No way. No way.
Oh my god.
I can't. There we go. We're making a big shark that's jumping out of the water.
Oh, that's terrible.
Now this is something Danny made. I don't know.